Hello, I'm Mrs. Arnold, and in this video we will talk about the basics of the atmosphere. The main idea of the video is that the atmosphere is divided into layers based upon temperature. Questions you should be able to answer at the end are: what is the gas and particle composition of the atmosphere? And what are the 5 layers of the atmosphere? So, atmospheric composition. In the atmosphere, of course, we have air, and air is a combination of different gases. And the gases that we see in our atmosphere can be classified as either permanent or variable. And air also contains particles. And these particles are dust, water droplets, and ice crystals. The permanent atmospheric gases are nitrogen, and oxygen. As you can see from this picture, nitrogen is 78% of the atmosphere, while oxygen is 21% of the atmosphere. These are considered permanent atmospheric gases because the amounts of nitrogen and oxygen are fairly constant over time. Variable gases in the atmosphere are gases whose concentrations change over time. So they're not as constant as the concentrations of oxygen and nitrogen. Okay. Examples will be water vapor and ozone. These two gases can vary significantly from one place to another place. And of course, water vapor and carbon dioxide play a role in regulating the amount of energy the atmosphere emits and absorbs and emits back to Earth's surface. The first variable gas we are going to talk about is water vapor. The concentration of water vapor varies with seasons the altitude of a particular air mass. And with the properties beneath the air mass. So the properties of the surface beneath the air. And at a given place and time, water vapor concentration can be as nearly as much as 4% or as little or nearly zero. Our next gas that varies in concentration in the atmosphere is carbon dioxide. Carbon dioxide makes up about 0.038% of the atmosphere. And we know the following, but we will write it here. During the last 150 years since the Industrial Revolution, the concentration of carbon dioxide has increased due primarily to the burning of fossil fuels. And when this happened, the concentration of carbon dioxide was around 0.028%. And you might ask, how do we know that? We know it because we can look at the ice cores data that will tell us how the atmospheric composition was 150 years ago when that snow fell and became ice in the polar ice caps. Okay, carbon dioxide is cycled between a few places. So just like water is cycled, there's the water cycle. Carbon also has a carbon cycle. So it cycles between the atmosphere, living organisms like you and me, the oceans, and Earth's rocks. Our next gas is ozone. So ozone is going to be formed by the addition of an oxygen atom to an oxygen molecule. So that makes the molecule O3, which is ozone. Most ozone is found in the ozone layer, but we do have some ozone on the surface closer to us. And the ozone layer is about 20 to 50 kilometers above Earth's surface. And the max concentration of ozone is 9.8 times 10 to the 12 molecules per cubic centimeter. This ozone is going to vary seasonally at higher latitudes. It reaches a minimum in the spring. And what we have seen is during the past decades, ozone concentration over Antarctica has dropped due to the presence of CFCs. But what we have also seen is that since most of the world has stopped using CFCs, then the hole in the ozone layer is closing up, which is pretty cool. So the ozone is really important and also very helpful because it blocks harmful UV rays from reaching Earth's surface. So it is important that we do the things that takes care of it and stop doing the things that breaks down the ozone, because UV rays are cancerous and we don't want that. We don't want that. So atmospheric particles are in the atmosphere, as I mentioned earlier. These are variable amounts of solids in the form of particles like dust, salt, and ice. Wind carries dust and soil and salt particles into the atmosphere. And airborne microorganisms like fungi and bacteria can be found attached to these dust particles. And so that's how they travel around in some instances. The atmosphere is divided into 5 layers, which we are going to talk about. These are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And this illustration can be found in your textbook. It's really cool because it shows, the certain things that you can find in the different layers. For instance, bacterial life can be found in the stratosphere. The stratosphere is also where planes are going to fly at. The International Space Station is in the thermosphere, and so forth. Our first layer is the troposphere. This is the layer closest to the Earth's surface. And it contains most of the mass of the atmosphere. This is because the other layers are not as densely packed. Their gas, or I should say, their gas particles are very spread out. Weather is going to occur here. So this is a layer where weather happens. And I mentioned that the main idea of this video is that the atmosphere is divided into layers based upon temperatures. So pay very close attention as to what happens in each of these layers when we talk about temperature. In terms of the troposphere, the temperature in the troposphere is going to decrease as you get higher. So as you get higher, the temperature decreases. So temperature decreases as altitude increases. This is not going to be the case for every layer. Different layers do different things, which is why we have layers, because we divide them based on how they act, temperature and particle wise too. Okay. And we have something called the tropopause. So the troposphere is going to end at the tropopause, which is about, oops, I spelled that wrong, 9 kilometers at the poles, 16 kilometers at the tropics above the surface of the planet. And the tropopause is going to be the altitude where the temperature stops decreasing. Then we get to the stratosphere. So the stratosphere lies above the tropopause. And in this layer, the temperature mainly increases with, or I will write as altitude increases. This is where the ozone layer is. And 99% of the mass of Earth's atmosphere is below the stratopause. So you get to the stratopause once you reach the end of the stratosphere. And the stratopause is about 50 kilometers above Earth's surface. And this is where air temperature stops increasing with altitude. So remember, with this troposphere, we had the tropopause, which is when the air temperature stopped decreasing. And here we have the stratopause, which is where the air temperature stops increasing with altitude. So that's how we know we're about to enter a new layer. That layer is the mesosphere. This is above the stratopause. And it is 50 to 85 kilometers above the surface of the Earth. And in the mesosphere, the air temperature decreases with increasing altitude. And a key thing here is it's cold because very little solar radiation is absorbed in this layer. And of course, we reach the mesopause where the temperature stops decreasing. And once we reach the mesopause where the temperature has stopped decreasing, we know then that we are entering a new layer. That layer is the thermosphere. The thermosphere is the layer above the mesopause. It is 85 to 600 kilometers above Earth's surface. And this is the layer that absorbs solar radiation. There's a low density of air that causes temperatures to rise. And this is the thermosphere, which, tells us something about it. It's very, very, very hot. Okay. Well, I can say it's not. The temperature is really high. The temperature can be as high as 2,000 degrees Celsius, but for us, it will feel cold because of the fact that there's a very low air density. So there's very, very few particles up there. So even though those particles are moving around a lot because they have crazy energy, which is why they have their temperature is so high, we won't feel that as heat because there's not enough of them. And this layer contains the ionosphere, which is made of electrically charged particles. And this is the layer that has the northern lights happening in it. So our very last layer is the exosphere. This is the outermost layer of the atmosphere. It lies 600 kilometers to 10,000 kilometers above Earth's surface. And this can be thought of as a transitional region between Earth's atmosphere in outer space and also the number of atoms and molecules in this layer become very small as altitude increases. Today, we learned about the composition of the atmosphere and the layers of the atmosphere and how they differ. I hope you have a very wonderful day.